Right. So coming to the chapter electricity. Electricity or current electricity or electric current. Right. And as previously I gave a brief overview of our chapter. Right. Based on that we will discuss. But let's take a little introduction about our chapter. So current electricity or the electric current is the important source of energy in the modern times. So electricity is used in our homes, in industries and in transportation, whatever, right? So playing a very important role in our day-to-day life. If we bring a plastic spoon near a very small pieces of papers, we understand that the small pieces of papers are attracted towards the rubber spoon. So as we know, due to some forces acts, that force is called as the electrostatic force. That force is called as electrostatic force. Due to the electrostatic force, the small pieces of papers are attracted towards the charging pump, as we know. So from these observations, scientists are says that about electric charge. Electric charge. So what is meant by the electric charge? Electric charge is the characteristic property. Electric charges is the characteristic property. Characteristic property of a substance or a matter which shows electrical phenomena. It shows electrical phenomena or creates an electric field. Creates an electric field. So electric charge is the property of a substance or a matter or a material which shows some effect is called as an electric charge. So there are two types of electric charges. One is positive charge and another one is negative charge. Two types, positive charge and the second one is negative charge. Positive charge and negative charge. So in the chapter class 8 some natural phenomena we already discussed. So positively charged objects are repel each other. Negatively charged objects are repel each other. One positively charged object, one negatively charged objects are attracted each other. Opposite charges or unlike charges are attracted. Then similar charges or like charges repel each other. Right? So Coulomb. So Coulomb is the unit of electric charge. Coulomb is the unit of electric charge. So we can represent with C capitals. We can represent with C. So the SI unit of electric charge is Coulomb, which is denoted by the letter C. We define this unit of charge as follows. 1 Coulomb is the quantity of electric charge which exerts a force of. So Coulomb is the unit of Coulomb is that quantity. Coulomb is the quantity of electric charge. Which exerts a force exerts a force of 9 into 10 power 9, 9 into 10 power 9 newtons. Force of 9 into 10 power newtons on an equal charge, placed at 1 meter away. Placed at 1 meter away. So, electric charge nothing but on a coulomb. Coulomb is the quantity of electric charge which exerts how much force? 9 into 10 power 9 newtons and the equal charge placed at a distance or placed 1 meter away from it. So there are two types already we know. The matter consists of two electrically charged particles. One is positively charged particles are called as protons. Then negatively charged particles are called electrons. So positively charged particles we can call as the protons, and these are the electrons. Protons and electrons. So a proton possesses a positive charge of 1.6. Charge of electric charge is 1.6 into 10 power minus 90 coulombs. Charge of proton is 1.6 into 10 power minus 19 coulomb. So as electron possesses a negative charge of 1.6 10 power minus 90 coulomb. So electric charge. So the unit of electric charge is coulomb. The unit of electric charge is coulomb. Right. So 6.25 electrons taken together constitute 1 coulomb of charge. So SI unit of electric charge is coulomb is equal to D. So 1 coulomb of electric charge. 1 coulomb of electric charge is equal to 6.25 is equal to 6.25 into 10 power 18 electrons. 10 power 18 electrons. So thus coulomb is a very big unit of electric charge. So 1 coulomb of electrons is 6.25 into 10 power 18 electrons. So based on that number of free electrons, based on the free electrons, materials are classified into two types. One is good conductors and insulators are the good conductors. Good conductors and insulators. So in the electric circuit or fast electric current is caused by the flow of electrons. So flow of electrons, nothing but a flow of electrons. So those substances through which electricity can flow easily are called good conductors. So all the metals are good conductors of electricity. So these are very easy. Then those substances through which electricity does not flow are called as insulators. So glass, ebonite, rubber, most of the plastics are the good conductors, are the insulators. So why some of the materials or some of the substances are good conductors and some are insulators? Because of based on the presence of free electrons. The materials are classified two types. One is good conductors and another one is the insulators. So the electrons present in the insulators are strongly held by the nuclei of their atom. Since no free electrons as we know, every material is made up of very very small particles we can call as protons, neutrons and electrons. Here, so when these electrons are negatively charged particles are bounded by the nucleus strongly. So there is no free electrons. There is no free electrons in case of good conductors of electricity. Such as in metals, there are some free electrons. So these free electrons can flow from one place to another place when the electric conductor is connected in the electric circuit. So electricity can flow easily. So due to the presence of free electrons, then the material allow the electricity or not. So based on this, electricity is two types. One is static electricity and another one is current electricity. Static electricity and current electricity. Static electricity and current electricity. So we are using in our home is current electricity. Then the other one is static electricity. So the static electricity is caused by the electric charges which are at rest. They did not move themselves. So even though they did not move themselves, they create some electric field. So or create some electricity. Such electricity is called as static electricity. So if the electric charges are can flow from one place to another place, then such electricity is called as current electricity. Current electricity or can call as electric current. So here the current means flow of electric charges. Flow of electric charges. So as when a glass rod is rubbed with a silk cloth, with a woolen silk cloth, and the charge acquired by the ebonite rod is with woolen cloth or examples. When we rub the any object with the other object, so when we rub the plastic comb with dry hair, so both are the get electric charges, but these charges cannot move themselves, but they create electricity. Such electricity is called as static electricity. The lighting which is we see in the sky during the rainy season, the lightning which is usually seen in the rainy season in the sky is the example of static electricity. Whereas in current electricity, the electric charges are in motion, means and produce an electric current. The electricity which is used in our homes is the current electricity, because the electric charges can flow from one place to another place. When we switch on, the electric charges, nothing but the free electron, can transfer or can move from electrical appliances to the switch on. When we switch on, the electric charges are moved from electric board to electric appliances. This is happened in electric current. Then regarding to this, there are two important terms. There are two important things in our chapters: electric potential and potential difference. Electric potential and electric potential difference. So let us understand what is meant by the electric potential and the potential difference. So when we place a positive charge, in an electric field, as so is the characteristic property or substance which show electrical phenomena and create some electric field. In that electric field, when we place a positive electric charge or a positive test charge is placed in the electric field, due to the another charge, it experiences a force. Two types are positive and negative. So due to the different forces are in electric, due to the different charges are in electric field, some forces exist between the a positive test charge and the another charge. So work has to be done on the positive test charge to move it against this force of repulsion. So in the electric circuit, electric field is formed that electric field is actually formed by the positive charges. In these positive charges, when we place one more positive test charge, generally what will happen? Repulsion takes place. So, to overcome the repulsion between the two positive charges, we need to do some work. So that work is called as electric potential, or simply we can call as potential. So the electric potential or simply potential is defined as the work done in moving a unit positive charge from infinity to that point. If the unit positive charge is placed in a electric field, if a unit positive charge is placed in electric field, so if it is a electric field, if you place a unit positive charge, so the another positive charge also is there. To overcome this repulsion between these two positive charges, they need to apply some force. When the force is applied, some work is done. So the work done in moving a unit positive charge from infinity to that point. From infinity to that point. To move the positive charges in electric field, we need to do some work. So that work is done to move a unit positive charge in electric field is called as electric potential, or simply called as the potential. So a potential is a symbol. Potential is measured with volt. So potential is denoted by a symbol V. Potential is measured with V, symbol with V, and measured with volt. So a potential of 1 volt at a point, 1 volt at a point means 1 joule of work done. 1 joule of work done. 1 joule of work done is done moving in 1 unit positive charge. 1 unit positive charge is called 1 volt. 1 volt is if 1 joule of work is done to move a unit positive charge from infinity to that point, infinity to one point, is called as potential or electric potential. A more common term used in electricity, however, is potential difference. So potential difference means the potential difference in the electric circuit is defined as the amount of work done, in moving 1 unit charge from one point to another point. So potential difference you can write into P simply. Potential difference is PD is equal to work done by quantity of charge move. So work done by quantity of charges move. So we can represent it. V is equal to W by C. So instead of C we can write Q. Electric charge. If W joules of work has to be done to move Q coulombs. Coulomb is the unit of electric charge. From one point to another point. Then the potential difference V is equal to W by Q. Then W means work done and Q is the quantity of a charge. The SI unit of potential difference is volt. denoted by letter B. The potential difference is almost sometimes written as symbol P. Potential difference, instead of writing all over, you can write PT. Same unit volt. Same unit volt. So 1 volt is equal to 1 volt is equal to 1 joule by 1 coulomb. 1 joule by 1 coulomb means work by quantity of charge. Work by quantity of charge. So 1 volt is equal to 1 joule by 1 coulomb. So 1 volt is said to be if 1 joule of work is done to moving 1 coulomb of electric charge from one point to another point. One point to another point. So this is about electric potential and the potential difference. So the potential difference is measured by using a device called voltmeter. Voltmeter. Voltmeter is a device used to measure the potential difference. Potential difference in a electric circuit. This voltmeter is always connected to the parallel in the electric circuit. In a electric circuit. So if it is an electric conductor, then here we have to connect the voltmeter. Connect the voltmeter because of it is the difference between ends. One point to another point. From if you take this is a conductor, so here there is some difference of voltage. There is a difference of electric potential R. So the difference from this point and this point we can call as the potential difference. So to measure the potential difference of electric conductor in a circuit, we use one device called as voltmeter. This device is called as voltmeter. This voltmeter is connected in a parallel. The 2 points where the potential difference is to be measured. So a voltmeter has a high resistance so that take a negligible current from the circuit. So the term volt gives rise to the word voltage. Voltage is the another name for potential difference. Voltage. Voltage is the another name for potential difference. High voltage of current, low voltage of current. So these words are using in our day-to-day life. Right? So let's take one problem regarding the potential difference. Then start the session. So I hope you understand this. One problem regarding the potential difference. Because of in this chapter problems are there, so they are very important. Let's take the problem. How much work is done? Problem. How much work is done? How much work is done in moving a charge of 2 coulombs from a point at 118 volts to a point to 128 volts. How much work is done in moving a charge of 2 coulombs from a point where to where at 118 volts to a point to 128 conductor is connected. So this is the initial point 118 volts and this is the another point 128 volts. Okay. Then if the charge is moves from here to here, from one point to another point, how much work is required? How much work is required? So what is meant by potential difference? Amount of work done or the work is done to move a unit charge from one point to another point. So let us know. So we know potential difference. PD is equal to work done by amount of or quantity of charge. Amount of quantity of charge. So let us write first of all the given values. Charge is given quantity of charge. Quantity of charge Q is equal to 2 coulombs. Then potential difference. Potential difference PD or V is equal to from 118 to 128. So here to here difference, then 128 to 118 potential. So that is equal to 10 volts. That is equal to 10 volts. Right? Then in this problem what we need to find how much work is done. So from this work done is equal to potential difference into quantity of charge. That's equal to potential difference in 10. Then quantity of charge, so 20 joules. So how much work is done? 20 joules. 20 joules of work is done to move a charge from the point 118 volts to 128 volts. Right? So this is a problem regarding to potential difference. So thank you so much. Signing off.